All right, everyone. So this meeting is mostly just going to talk about the direction that we're taking with the semester starting. Um, to start with, we will have our meetings starting the second week of school. Our meetings will start at 6 o'clock. I've already kind of started implementing that over winter break. So we may just continue doing that because we don't overlap with anyone's time if we start that early. So not to mention that means everyone can enjoy their Friday night a little bit more instead of coming here at 7 o'clock if they have class till 5. So our meetings will be at 6 to 9. That's our lab time. I don't know if we're still going to stick with our meeting time being overlapped with our lab time or not. I haven't decided if we're going to stick with that. What has y'all's experience been with that so far? Are you okay with our meetings happening and then directly after we do like our lab, whatever we need to do in the lab?
I mean, I'd be fine with that because if the meeting ran short for whatever reason, we could just use the rest of that time for whatever else we needed to do.
Yeah, because I know I usually try to keep the meetings less than like 45 minutes. And we have a 3-hour block. So it's from 6 to 9. So even if our meeting did run the full 45, we can then just like do whatever we need to do in the lab and call it a day after that. I just mostly try to avoid asking for too many individual days from y'all. Also, I was really happy to drop off the material for the machinist today. But then as I went to drop off the material, the lady said the machinist is no longer machining anything for the next 2 months. I messaged him yesterday at 2:30 and there was no problem then. And it didn't seem like there was going to be an issue. And then he said, or he didn't even directly tell me. I sent him an email to confirm, to ask like if there was maybe some miscommunication, because he seemed pretty confident that there wouldn't be an issue getting us the stuff before February 1st. And yeah, apparently now he's out of town. And there's no machinist for the mechanical engineering department. And the lady said that we just can't get our stuff machined through them because they just don't have a machinist until he comes back. So that's something we're gonna have to figure out. I know that we really wanted to do all the boat tail stuff and we wanted to go ahead and get that machined, but yeah, we need to find other resources for machining. That's not gonna work for us anymore. So do y'all happen to know anyone who does machining? I know previously we've reached out to Eason before, but I don't personally know too many people who will machine things, especially, you know, pricing wise, because U of H would have done it for free.
I'm sure we can reach out. I know also TXRX Labs has machining stuff, and a bunch of the TAs for the mechanical engineering department go and work with them. So they're technically allowed to use, as far as the last time I heard, they're allowed to use the machines and stuff in there for free for any personal projects. So that might be an option.
Okay. You said TXRX?
Yep.
So
I guess
yeah.
the only caveat with that is that it'd be students making it with whatever experience they have.
Yeah, and I guess we would also have to figure out what all they have access to, because we do still need someone who has access to a lathe. Let's see. Meeting time, that, yeah.
Actually,
Okay.
I think Elise from Propulsion, she is one of those TAs. So she can
Yeah.
probably go out there. I don't know how experienced she'd be with like the machining operations, because that's besides the point. But yeah, she could probably give us a lot more info on that. I'll reach out to her.
And Haley,
Yeah.
as far as the material, did you just end up doing the cedar that you were telling me about?
Yeah, so I ended up getting cedar from a place called Clark Hardware or Clark's Hardware Lumber, Hardwood Lumber. The piece was like $50 for the 8x8 by a foot of cedar, which the machinist said he wasn't going to have a problem machining, but everyone seems pretty hesitant. Except for the machinist, everyone was pretty hesitant about using softwood. So hopefully
Yeah.
someone who's less experienced with a lathe won't have a problem with that. They also recommended that we epoxy because there's a crack down the side of it. It's like, I want to say it's a little like right around 2 inches. They recommend that we just fill it with epoxy. I
Mhm.
was there when Irvin picked up the piece for me. Otherwise I would have asked them if they, had a different piece that was just whole, that we didn't have to actually epoxy, but yeah. And they left another note on the actual wood itself. Yeah, everything is sitting in my car now because I had to lug it over to the engineering department. Then they were like, take it back. Yeah. And then Gustavo had met with all of the leads and everyone came up with their own little chart. So this is ours. So this is kind of just like a projection of the things that we're expecting to work on. Like I said, these due dates aren't going to quite align with some of our stuff because we are delayed based on some of the machining that we wanted to get done. I still have an accent. So yeah, this is kind of just a projection of the things that we want to get done. I still need to work on putting dates on more of these things and updating this stuff, but I can share the link for this and then y'all can have a better idea of what to expect this semester. As far as what we were going to do next, on top of the schedule I wanted to get today, I also was going to make slides about like the step-by-step process that we were going to take with the boat tail. But we need to first get the wood machine before really, we can still learn how to do it. It's just, I would want to learn it sooner to when we're actually going to apply the information. But what I want to go ahead and do soon, since we actually have access to it, is getting the bulkheads done. So we have the couplers, and we determined that the couplers and the nose cone was just going to come from Oberon, so we weren't going to buy those. And the airframes are going to come in about 4 weeks. So for the couplers, I think 2 of the bulkheads are still good, but I think the other 2 need to be replaced. And what they did for I don't know if it was for Oberon or Prometheus, but they just cut them themselves. They didn't purchase the bulkhead. They just cut out 2 circles of G10 fiberglass and just glued them together to fit on the coupler. So we can do that pretty easily ourselves. We just need to go ahead and figure out how exactly we plan on cutting the fiberglass, and then of course making sure it's the right measurements for what we need. So that was gonna be like one of the first things that I wanted to get done this semester. And then after we get the airframes in, we can start worrying about matching up the holes of the coupler with the holes of the airframe or filling those holes, which would be something else that we would need to do. So once those come in, that can be something that we tackle. We can just go ahead and uncheck some of this stuff because so yeah, I still intend on making the sheet, like the step-by-step stuff that we need to do for the boat tail. I'll just share that with y'all once I finish it. I should have it together by next week, and then I can have more of a clear schedule clear idea of our schedule next week, once I've figured out some of this stuff. Any questions up till this point? Or anything in here that you want to see that you haven't seen yet? All right, well, I might as well go through everything just so we can all be on the same page. So right now it's categorized by the different component. So for the fins, we still need to finalize a design, worry about actually purchasing the material for that and then fabricating it. I know it's been mentioned that we can use Dom. Dom's dad apparently has a laser cutter or something that we should be able to use. And that's if we want to do it ourselves. We also need to determine which material we want to do the fins out of, because we might have to be doing it out of carbon fiber. For the MMM, we still need to finalize a design. We then need to purchase the materials for it. We need to fabricate it. We need to test fit it. We have the design that we want for the motor block. And we have to produce the other centering ring for the motor. And then as far as couplers and bays go, we already have the couplers and bays, but now we need to patch anything and screw and put in any holes that we need to. One idea for how to actually get the holes to line up is to 3D print a sort of guide for it. And then of course the bulkheads, which is one of the first things that we can tackle. And then we'll need to reach out to avionics and payload to make sure all the current holes that are on the bulkheads are going to match up with the things that they need to put on there. And then for the bolt tail, I'll go into even more detail than this, and it'll be a whole separate document for us to look at. I'll probably do it as a presentation as opposed to a document, just so it's easier to follow. But yeah, this is kind of the steps that we're expecting for this. I think everyone has watched the video, or at least the last time I had asked in a meeting, everyone had watched the video that we had shared. And there's been a few different talks as to how exactly we're going to cut the end of it. So if we're going to do like a nose cone shape and then just chop off the end, if we're going to do some kind of like way to end it off nicely without having to cut into it. So that's something that's still kind of in discussion. Airframes obviously been ordered, but as far as coding goes, AI Coatings agreed to code it for us, and we still need to have a separate meeting with them so then we can give them all of our criteria and then they can go ahead and do that for us. That'll be one of the last things that we do. And then I assume they would also coat our fins for us. So we'd also need a design for them. And then these last few things are more so geared towards actual, end goal of competition, but also kind of like a framework with, bill of materials, consolidated weights, dimensioning, and of course the tech report. Any questions?
I've got a question.
Okay.
So as far as the, I guess, criteria or process of fin design, how exactly is that going to function with us?
So it's more so in conjunction with analysis, trying to figure out something that's going to resist fin flutter, but is also going to keep us within stability and also help us with apogee. So there's a few things to consider. And we can always ask analysis more about that process. But right now it's kind of just shuffling a lot of numbers and kind of playing around with designs. If you want to see the kind of idea that Gustavo had. I'm sure he would have no problem sharing his screen and showing you the open rocket for it. But yeah. And then I know at one point there was discussion with changing the design because we wanted it to be in conjunction with the boat tail. But I think that's just going to be too much for us to do. So
Yeah, so the big thing with FinFlutter, uh, like the fin design, like Haley was mentioning, is we want the stability between 1.5 and 2.0. Those are the ranges we're acceptable or that are acceptable at spaceport. And it's really hard to do that right now. The center of gravity is far enough backwards or far enough back on the rocket to where any fins that you add, if you want them to have a strong enough effect on the center pressure by moving back and stuff, you'd have to make them either really big so they stick out of the rocket quite a distance, or they reach backwards quite a distance. And the big thing with FinFlutter is the longer your fins are, the I guess the longer moment on that air has or whatever to make it like bend the fin. The more it can bend the fin, the more chances there are of breaking it. So it's just basically endlessly running around trying to see how thin, short, and far enough back you can make the fins without having them break. There's this calculator that was put up by Apogee Components or Apogee Rocket Components or whatever, their website. And you put in a whole bunch of parameters of the fin, so the thickness, the length, the root chord, the tip chord, all that stuff, the velocity, or sorry, not the velocity, the altitude you want to calculate the fin flutter velocity at. And essentially it tells you like a speed limit on the fins, how fast they can go without them shattering. So basically we looked at everything that is, well, we looked at the simulations for the rockets to try to find the fastest speed that we could potentially go at, which is somewhere around 500-ish meters per second. You take those 500 meters per second, and I gave it a factor of safety of 1.5, so that gives you 700 meters per second. So essentially you want fins that can go 700 meters per second. Then you go through and you find a fin geometry that gives you the stability you want. So it can either reach backwards and make the center pressure move backwards to increase the stability, or you can make them longer so they stick up further. That also increases your stability until you're at a happy range. I've been sitting around like 1.55, 1.6, somewhere around there. And then you plug everything into the calculator and it tells you the maximum velocity. And it'll also tell you the minimum thickness of the fins so that you can achieve that velocity. And everything that I've played around with gives us about 0.3 inches or like 9 millimeters. It's kind of thick. So you can play around with making it shorter and reach further back. And that allows you to go a little bit thinner, but then your fins are reaching quite a ways back. And you don't want them to reach too far back or your fins are going to crack whenever you land. Or they might flutter behind the fin, like where it's attached. I guess I can show this. Give it a second, it's loaded. So this is one idea. As you can see, the center of gravity and center of pressure are fairly close together. This is actually below the 1.5 limit. And this is only getting us to 28-ish thousand feet. But if we want to keep a MMM design, or something that's like inside of the straight section of airframe, then you have to have the fin stop right here. But you can't have the fin be right here without it reaching back, or else you're never going to get the 1.49 stability. Yeah, and it reaching over this edge right here is just a little bit too much. Then let's open MATLAB. This is going to take a second too. But yeah, essentially, you just don't want the fins too long, or else they can shatter, or too far back, or they can shatter. And it's just been trying to find that Goldilocks zone.
I have a question.
Yeah.
So this as like an idea to possibly bring the location of like the edge of the fins up a little bit, would it be reasonable to have, I guess, smaller fins, more like stretchers almost, that aren't necessarily super structurally sound, but you can maybe like fillet them onto the taper of the boat tail, just to kind of bring the center pressure back a little bit, so it'll give you a little bit more forgiveness.
So like bring this down to here.
No, it would,
Like
I guess
separate
the way that I'm
fins?
thinking of, yeah, separate. It would be separate from the ones that are connected to the MMM, but it would just be
So it's like another
epoxy.
fin that like fits into the ear. Is that what you're saying?
Yeah, it would be running along the taper of the boat tail. I don't know if I'm explaining it very well.
Yeah, like along this.
Yeah,
And it's just a separate fin that kind of fills in this hole.
yeah, essentially. I mean, just to, it doesn't even have to go too far out the diameter of the rocket, the full diameter. I guess we could play with it and see what type of numbers it gives us, but that was just my thought towards bringing the main fins forward a little bit.
I mean, it's in the realm of possibility. I'll look into it. But essentially with the calculator thing, you plug it into here, and then there's the root chord length, the tip chord length, the height of the fin, the height you want to calculate at. I'm just doing worst case scenario, which is ground level, but I think the fastest speed is 8,000 feet. So I'll choose this one. And I'm getting the apogee, sorry, max velocity is here. Forgot how I looked at where the maximum velocity is. Okay, I think I just did this. So I'm gonna plot next to this. And you look at this for the maximum acceleration, which is I guess before burnout. And this, if you go all the way down, actually, we want altitude. Let's just follow this line down up to here. So it's gonna happen around 7,000 feet. I don't know if that made sense. I want the maximum velocity, which is on the blue line. And then I find along that same point, which I'm just gonna use burnout, follow it over to the red line, which is altitude. And that gives us around here, which is around 7,000 feet. So we can plug that into the MATLAB. Our 8,000 feet. This is the shear modulus of carbon fiber, and then just some thicknesses display like as a range. We're gonna run it. Tell it we want to use Zenith's fins, which are those values. We'll run it. This is just a little visual. So this is the 750 meters per second, which is the 1.5 factor of safety. And then this is the thickness that you would need at, or the fin flutter velocity at each thickness. So this is in inches on the bottom axis. This is your velocity. So with a fin that is a quarter of an inch thick, you go up to like 500 meters per second. But if we want to hit that 1.5 factor of safety, we would need a fin thickness of 0.322 inches. So it's just running back and forth. And so, right, once you go back to MATLAB, sorry, OpenRocket, you come over here, you go to your fins, and then you plug in that 0.3222. This is, I think, a different fin than it was there. But then it updates your apogee, and this gives me an apogee of 28,000 feet. So technically, that little decrease in thickness makes it better, but I don't think these are that are here. But yeah. And then in terms of that, let's do this. This is another idea for the fins. This is considering we would put it on the boat tail. So if we were to put the fins on the boat tail, there is a little more things to consider, such as how are we going to glue it on? Is the joint going to be strong enough? All that stuff. But answers are out there. We just got to look for them. The second thing to consider is we don't, or at least I don't know how OpenRocket calculates these fins if they are not on the outer diameter of the rocket. So to add fins to the boat tail here, what I had to do is I added a body tube, which is 0 inches long at the end of the taper. That way I can add the fins to that body tube section. It essentially doesn't exist, but it's just so I could add it. Then I add the fins, but as you can see, the fins kind of go inside of the airframe. And that gives me a pretty good apogee of 28,000 feet, 28,500 feet. Not 30,000, but fairly close, I guess, with a decent stability. But if I go over here and I look at the shape of the fins, and I try to make it like a fin tab. So let's say I make it like that, and this is going to be the 1 inch to the thing. So by making that flat thing right there, which should have not changed much, takes away like 700 feet or 7,000 feet. No, 700, yeah. So there's something weird because this should, like, how the fins react inside of the airframe shouldn't be calculated into the apogee, but it is. So I can't say for sure how that would react. We'd have to, I guess, look deeper into it.
I just have a question about everyone, I guess, attending the lab in person next semester. Does anyone have an issue with the biweekly testing that we're enforcing? Is everyone gonna be okay to, just get a COVID test and then come into the lab that Friday?
Actually, can those just be done at the campus testing site?
Yeah.
And are those instant, or what testing is they do over there?
It's the PCR testing, and the results are usually 1 to 2 days.
Okay, sounds good.
Yeah. So
Wait.
when I got tested on Monday, I got my results by like Wednesday at like 2 a.m. So basically like Tuesday night.
Wait, is that test required for everyone, even we already vaccinated?
Yeah.
Very cool.
I'll be messaging everyone else as well, just kind of asking them the same thing, and then, just asking if they're, excited about the semester and everything, just to, I guess, reach out to all of y'all. I guess I know I've mentioned a few issues. If y'all come up with any ideas, or if you need me to restate any of them, just let me know. because we definitely have a lot of things to figure out this semester. I'll have a more thorough presentation for next week when we start the semester.
Also, if any of you want to help out with the fin stuff or how we're gonna get the hotel design and everything, help me crunch numbers, I would greatly appreciate it.
Yeah, I was actually about to ask you about that. I was gonna see how I could help, or like if you could try to send the file to me so I could try to look around a little bit, see if I can make
Great.
anything happen. But yeah, I guess we can
That'd be
talk about that later or something.
Yeah, I'll probably try to conduct everything the way it was done last semester, where if there's anything that needs to be done outside of the Friday meeting, I'll try to host like a secondary meeting where we can just talk about anything that needs to be sorted out, before that following Friday. But yeah, we do need to figure out the fin stuff so we can have like a smaller meeting. I know technically we still have after Tuesday's meeting, we do still like technically have a meeting time after that available. But that's also when school starts. So if y'all have any friends on the team who aren't sure if they're going to be active next semester, hype them up, encourage them to come back. There's a lot of cool stuff that we want to do, and I would love for all y'all to be a part of it. So, anyone's welcome. Doesn't matter how active you've been up to this point, just everyone's welcome. That's all I really had to cover though. I'll go ahead and stop the recording here.